In this video, we're going to look at some window functions in SQLite and then ultimately use one of the window functions, percent rank, to take some data and get the first quartile, the median, the first quartile, the third quartile. Okay. So the definitions of these things can depend on how much data there is. So I made some very simple tables with the numbers with values 1 to 10, 1 to 11, 1 to 12, 1 to 13, because they're just different cases for getting the first quartile, the median, and so on. So I just made different tables with different amounts of data, but just the numbers in order, so it'd be easy for me to sort of see what I am expecting. Okay. So the first query here is just a standard like aggregate query, getting the minimum, the maximum, and the average, and I chose table 1. And so here we see that the minimum was 1, the maximum was 10, and the average was 5.5. Okay, so that's all good and fine. All right. So next, I'm going to look at one of the window functions. And first, I'll look at the end tile. And it will break it up into sort of quadrants or quartiles, and give the first values a 1 to say they're in the first quartile, and so I'm not getting the first quartile, but I'm seeing which values lie in a first quartile if I choose A4. Or I could choose 5, and it would be like breaking it up and breaking the data up into quintiles. Here I decided to go to table 2. And and we have to say here in the n tile how many tiles I want, what n is. And so in this case I said 4. And it doesn't break. This has 11 pieces of data, so that doesn't divide evenly by 4. And so it's the higher quartiles that we sort of, I don't know, steal from or something. So there are 3 1s and 3 2s and 3 3s, but only 2 4s in this case. Okay, but we also have to say what we are, how we are ranking them, how we're ordering them. And so we're ordering them by value ascending. So I could also, flip it if I want. So, and do descending. So here I said that the low values are in my first quartile and my high values are in my last quartile, if you will. I can uh, do a different over order in the descending and change that. So now the high values are in my first quartile. Simple enough. Okay. So that is n tile. And so you sort of want to turn the n tile into a way to get the first quartile and the third quartile statistical measure of some data distribution. But I'm actually going to go over to percent rank to do it. I found that a little bit easier, though what I have is a little bit cumbersome, so it's even that's that not that easy. Okay, but let's try, instead of n tile, let's try a different window function, rank, and it's just going to uh, put the data in some order. Again, I chose, in this case, descending. And so I said my value of 11 had my rank of number 1 on down. So that is rank. And then there's a distinction between rank and dense rank. With my data just being simple numbers, all different, it doesn't make a difference. But if you have multiple copies of the same value, then rank and dense rank are a little bit different. But that distinction wasn't very important to me here. So, and I'm moving on to percent rank anyway. So percent rank is, I'm going to Here I chose again table two. And so I have taken my data, and the first value is has a percent a rank of 0, and then it goes up to a percent rank of 1. And that is the idea of percent rank. So I'm back to ascending order. So 11 is at my top, is sort of, I don't know, 100%. 1 is at my bottom, it's at 0%. And then we see here for this particular set of data that 6 is at zero point 0.5. And so this is going to get us toward the idea of the median, because I'll want to know, do I hit exactly zero point 0.5? If I hit exactly zero point 0.5, that is the median. So the median is the middle value. So in this case, the middle value is the 6. There were 5 values higher and 5 values lower. And so it came out at exactly zero point 0.5 in this percent rank. Um, okay. And then down here, I went over, switching different tables just to uh, the things are slightly different. But now I'm going over to table one, which only had 10 pieces of data, so it does not have a value exactly in the middle. But I'm also going to calculate not this percent rank, but I'm going to subtract from the percent rank a half. And so I go all the way from minus a half to plus a half. And we see here these two values on either side of 0 are what I want to work on to get my median. Um, Also, you see, I can change this uh, to a quarter, and I get the values that will be involved in my calculation of the first quartile. And if I said 0.75 and look at where it sort of changes from 0, from positive to negative, we see the two values involved that are going to be involved in my calculation of the third quartile. So that brings up some things about the definition of quartiles, which are not always consistent, a little bit, or at least maybe they're consistent but can be confusing. So I'm going to just compare uh, things in Excel and R and like Wolfram Mathematica, just to and take the same data of 1, 2, 3, 4, 5 up to 10, 11, 12, 13 different sets of data. So here we are in Excel. I have the data 1 to 10, and I calculate. They make a distinction in Excel between the inclusive and the exclusive. So that's sort of, are we, when we're, everybody agrees, inclusive and exclusive agree on the median. And then there's a question of, are we counting the median uh, in, I think that's what it is, in the exclusive. Okay. But so here is the inclusive version for 10 pieces of data, 3 and a quarter, 5.5, 7.75. And then down here is their exclusive version. Okay. So I'm going to, when we get back over to SQL, I'm going to be doing this inclusive version. I'm going to, so we see here, say with the 10, let's do the 11 is the easy. Okay. So there we are at, with 11, 6 breaks it in half. And then we are looking for the middle of this, including the 6. And so then the middle, there's the 3 and the 4. And so we take the average of that, 3.5. Okay. Down here, if we exclude the median, then we have 1 to 5, and then 3 is the middle. Okay. So that is sort of what we have going on Excel. There's two definitions, an inclusive and exclusive. Um, let's just see what R does. So here's the data. Here's 1 to 12. I just did 10, so let me switch it back to 10 and run that. And so here are the quartiles according to R, and that's agreeing with the inclusive definition in Excel. I'm going to come back to this in a second. Now let me show, uh, let's do the top one here, the numbers 1 to 10, and the quartiles function in Wolfram is giving me 3. Okay, so the inclusive version in Excel gives me 3.25. The exclusive version gives me 2.75 for the numbers 1 to 10. And the quartiles in Wolfram seems to be giving me 3. In some sense, it seems to be getting the average of the inclusive and the exclusive. Okay. And then that just takes me back to R for a second. Now in R, I can take the same data, the 1 to 10, and ask for the box statistics. So that's down here in my console now. And I'm getting 1, 3, 5.5, and 8. So when I ask straight up for the quantile, it's giving me what corresponds in Excel to the inclusive version. But when I ask for the stats that it's going to use in a box plot, it seems to be doing that sort of uh, average of the inclusive exclusive thing that we see in Mathematica. So just again, there are these different definitions floating around, and you need to be sort of careful about which one you're going to do. I'm going to when I go back to SQL, which is next, I want the inclusive one. So I want it here like the straight up quantile, or over in Excel, the one that has INC inclusive. Okay. So that's what I want to do. I want to play around, use this percent rank window function in SQL, and I'm going to try and get a quartile, first and third, and I'm going to do the what Excel calls the inclusive version. Okay, and we saw here again that if I did percent rank, and this was minus 0.75, so I'm working sort of on the third quartile here, we see that there are two numbers on either side of 0. So that so if I subtract off the fraction I want, then on sort of either side of 0, that's this. That's the sort of the 2 I want, and then I want to take some average of those two. But you see here in this 7, 8, and back down here, I'm into, let me go to the quarter because that's what I have next here is the quarter. So 2, 5. Um, so now I'm where I switch from the negatives to the positives is between 3 and 4. And I am looking for, the 3 is closer to the 0.25 than is the 4. So I want to, weight it more. I want it to be closer to the 3 than to the 4. And we saw that here, that it was 3.25. Okay. So here I am doing I'm doing what I just did above. I'm finding that subtracting off the 2, 5 and finding the difference. But now I'm taking the absolute value of the difference. So I'm not going to have negatives and positives, but I'm finding the maximum value where the difference was less than zero. So my difference was less than zero for 1, 2, 3. The maximum value is the 3, but I also want to know this, how much it was different from that 3, how much the percent rank was different from the 2, 5, but I want its absolute value. So that's what I'm doing here. I'm taking the maximum. Here's my where the difference is less than zero. I'm finding the maximum value where the difference is less than zero, and I'm taking the absolute value of that difference. And then I'm unioning that with it's the other side. I am finding where the difference is bigger than zero. I'm finding the minimum value, so the lowest value where it was bigger, so that will be the 4, and finding the absolute value of that difference. So if I run that, I'm getting these two values, the 3 and the 4, and sort of some measure of how far they are percent rank wise from my target of 0.25. And then I want to calculate the difference. Now, what I have to watch here is for my one table, I think it is my table 4. So here was table 2, and it was 2, and I was closer to the 3. Here's my table 2, and now I'm sort of equal distance between the 3 and the 4. Here's my table 3. Again, the 3 and the 4, but I am now closer to the 4. And then in table 4, not 34, but 4, then I am like right on the nose with my table 4, which had 13. So my median was 7, and then I had something smack in the middle here. The 4 was smack in the middle of that. Um, is that right? So there were 6 below and 6 above the 7, and then if I'm including the 7, because it's inclusive, then the 4 is in the middle. Okay, and it's exactly in the middle. So that's what this said, that there was only with the union, if you have a duplicate, it only appears once. So now I only have one value. So now I'd like to use those weights uh, in for tables 1, 2, and 3. There were two values, 3 and 4, on different sides, different distances from my 0.25. But for table 4, it's like spot on, and there was only one value. So that brings up a case statement. Okay. So I am going to take this first case when the difference is 0. That's for my table 4. That's when I hit it spot on and there's only one value. And so when I say when that difference is 0, I don't know why exactly I say min, but okay. When the minimum difference is 0, I get the value. End of story. So that was table 4. Otherwise, I am taking my value and I'm dividing it by the difference. Remember then if I'm closer, I want to weight that more. So I'm not multiplying by the difference, I'm dividing by the difference. And then I'm taking a weight, which is the reciprocal of the difference, and multiplying it by my value, and then dividing by the sum of all those. And that just does this. Again, the table 1, I was the 3 was 3 times closer than the 4. In table 2, they were equidistant. In table 3, I was I was much closer to the 4 than the 3, and then in table 4, that was the spot on. So that was up here, the first case. Okay. So that's what I'm doing. So this is my crazy union. Uh, I'm doing right here. Let me switch it back to the 2 5. At what table? I'm on table one. So this whole thing here should get me the 3 2 5 for table one. Not table 12, but table two. The 3.5. And this is agreeing with what I have in Excel for the inclusive. Let's just finish it off. Table three, which was the 375, and finally table four. That'll be the special case. Keep doing that. Four. And there's the four. Okay. So that is a way, kind of cumbersome query, but a query to get the first quartile. I can change the 0.25 to zero point 0.5 and get the median. I can change the value to 0.75 to get the third quartile. Um, so that was fun. And then I just made, used Excel to get some random data. And so I generated some data and got the quartiles, the inclusive, the exclusive, and I did the average so I could compare to uh, what I get from Wolfram. In R, I ran it with this RD data, which is just copied over, and I'm getting the same as the inclusive. And then over in Wolfram, I took this data and it's doing the averaging of the inclusive and the exclusive. So I can compare that over here to these, the average of the inclusive and the exclusive. Okay. And then, but again, remember what I got in my, so I'm changing now to RD, the table RD. But what I did here in SQL with these window functions was the inclusive. So that's what I should be comparing to. 27.749999, 27.75. Okay, so I seem to have a way to calculate the first quartile, the median, the third quartile with a query using the window function percent rank. That's what I wanted to do with here, just having some fun with SQL queries and have window functions. Thanks for your attention.